0 and negative exponents. So let's use the power of the quotient property to simplify the expression. Write the quotient as an exponent. So the first one's done for us. When you divide and you have like bases, you subtract the exponents. And my old eyes really can't see those exponents there. So somebody tell me what the first one's going to be. So 3 to the 5th divided by 3 to the 3rd. What do we got? Roman.
3 to the 2nd.
Yep. 3 to the 2nd. And on the one below that, 3 to the 5th divided by 3 to the 4th. Tony. Just 3 or 3 to the 1st power. Yep, same thing. So then what do we end up with that last one in there, Alexis? It would absolutely be 3 to the 0 power. So it says, what expression did you write for 3 to the 5th divided by 3 to the 5th? Okay. We know, Alexis said it's 3 to the 0 power, and she's absolutely correct. What exponent did you use? We used 0. And then it says, using factored form, find the value of 3 to the 5th divided by 3 to the 5th. Meaning, let's expand this out. So 3 to the 5th means 3 how many times? 5 times, right? And then the denominator, same thing. And then when we go to simplify that, what is 3 divided by 3? Well, let's be careful. You are correct, but sometimes we get confused when we just say, let's just cancel. This is 1, right? And that's a 1, and that's a 1, and that's a 1. So what's my final answer? What? Where are you getting 5 from? Guys, what's 1 times 1 times 1 times 1 times 1? So then what is, okay, it says based on your findings, what can you conclude about the value of 3 to the 0 power? What's it equal to? 1. Now it says make a prediction about the value of any number raised to the 0 power. It's going to equal 1. Now it says use your calculator to check your prediction for several numbers. Is your prediction correct? So, okay, right side next to the windows, you type in 4 to the 0 power. You guys, the 4 of you in the front, type in 2 to the 0 power. Middle guys here, you type in -3 in parentheses to the 0 power. And then you guys over on the wall, you do in parentheses 1/2 to the 0 power. Okay. Windows, what do you guys got? 1. In the front, what do you have? 1. -3 in parentheses to the 0 power, we have? 1. And 1/2 to the 0 power?
1.
1. A non-zero, okay, a non-zero number. These are all non-zeros, okay? 4, 2, negative, a fraction. Okay, so any number other than 0, that's a non-zero number. Raised to the 0 power is equal to 1. So therefore, our general rule, A, any number other than 0 raised to the 0 power is, if we didn't have parentheses here. Yeah. Absolutely. So, good question. So, what if we didn't have, so let's take that -3 and raise it to the 0 power. But notice, I don't have parentheses there. So, what's that? What is really being raised to the 0 power right now? 3. Just the 3. So, 3 to the 0 power is 1 times that negative that's in front. So, the answer to this one would be negative. Awesome. Okay? Parentheses. That's why those parentheses are so important. Okay? Good question on that one. All right, so let's simplify this group. So what do we end up with? Like bases, add exponents, because we're multiplying. Alexis, what do we got? Yeah, It's just 7 to the third power. Absolutely. Okay. Number 7. Give me a step. Give me a step. Garrett. Oh, go ahead. Sure.
For that one, if you were like solve like the numbers.
7 times 7 times 7.
Would you add it being like for 7 to the third power would be then plus 1?
Is there a plus sign in here?
No, like,
There's a multiplication sign. And multiply. Okay. 7. Yeah. Give me the numerator. What do we get in the numerator?
4 to the second power times 4 to the sixth power would be 4 to the 8th.
Awesome. So 4 to the 8th divided by 4 to the 8th. And we could go about this 2 ways. What's anything divided by itself, guys?
1.
Isn't that a big old 1? Or if, because we're in the mode of exponent rules, when we divide and we have like bases, I'd get 4 to the 0 power, right?
Yeah.
But what do we know anything to the 0 power is equal to now? Okay. All right, flip it. So we got another chart to fill out. First one is done for us. Next one is what?
4 to the 1.
4 to the first. Next one.
Would it be 1?
Right, 4 to the 0. I'm just going to stick with the exponents, but you're correct in saying the value is 1, yes. Okay, I want to establish a pattern here. Okay. Tony, the next one. 4 to the negative 1. Okay. And last one. Okay. 4 to the negative 2. Okay. So now we've got some negative exponents that we haven't had before. It says, excuse me, what expression did you write for 4 to the 5th divided by 4 to the 6th? What exponent did you use? So 4 to the 5th divided by 4 to the 6th, you said it was 4 to the negative 1, and the exponent we used was negative 1. Now it says, using factored form, okay, let's expand, find the value of 4 to the 5th divided by 4 to the 6th. So 4 to the 5th we know is 4 how many times? 5 times. And then 4 to the 6th is 4 6 times. So let's simplify. Okay? So 4 divided by 4, 1. We get all these 1s here. What's left on top? What's 1 times 1 times 1 times 1 times 1? 1. So 1 on top, but what's left on the bottom? 4. So what could we say about 4 to the negative 1? What does it equal? It equals a fraction. And what is the fraction that it equals? We just came up with it. 1/4. So now that's not enough, really, I don't think, to see a pattern. Okay, so let's do another one. So let's see what happens. So using factored form, let's do 4 to the 5th divided by 4 to the 7th. Okay, which we came up with was that, 4 to the negative 2. We said in our chart, 4 to the negative 2, which is right. So now let's expand it and see if some of you can start to see patterns here. So we've got 4 or 5 times. And then we've got it 7 times. Good. 6, 7. Simplify it. What's left in the numerator? Anybody? 1. What's left in the denominator? True. 16, but let's keep it as an exponent so maybe you can see something happening here. Careful. It's 4 to the 2nd power, right? So let's talk. Blue. There we go. So in our chart, okay, up here, we said it was 4 to the negative 2. But when we expanded it out, we said it was 1 over 4 to the positive 2. Is anybody seeing any, and I'm going to sneak something in here, patterns happening? Compare the 2 yellow answers for the first example that I highlighted in yellow, and then compare the 2 answers that I've highlighted in blue. Think about it. 4 to the negative 2 is equal to 1 over 4 to the positive 2. And then in the yellow, I had 4 to the negative 1 is equal to 1 over 4 to the positive 1. So how would you write a to the negative 3 using a positive exponent? Who sees the pattern? I give you 3 of you. All right. That's all right. So what if I gave you an even number exponent? We had an even number exponent, the 2. Okay, the negative 2. Lily, what are you thinking? 1 over a to the 3rd power, which is absolutely correct. Okay, let's do another one. What about if I had 3 to the negative 3rd power? Who thinks they know what that's equal to with a positive exponent? Kim? 1 over 3 to the 3rd power. What if I had negative 5 in parentheses to the negative 2nd power? Who can tell me what that is equal to? Yeah. Nope. The negative exponent, I want to write it with a positive exponent. Alexis. What are we doing each time here? Okay. A to the negative 3 is 1 over a to the positive 3. 3 to the negative 3rd is equal to 1 over 3 to the positive 3. Oh, we put 1 over. The exponent can't be, well, it can be negative, but if we want to write it with positive exponents, how do I finish this one? What's my base? Careful, what's my base? Parentheses, negative 5, and what do I change the exponent to now? Positive 2. So my rule, a to the negative n. A to the negative n. Jacob.
1 over a to the positive n.
1 over a to the positive n. All right, hang on. Before we flip it, I think you guys can handle this. Ready? What if I had 1 over 2 to the negative 2? Who thinks they know that? Jake, what do you think?
2 to the positive 2 over 1.
Drop the mic.
Mic drop.
He's absolutely correct. Yes. What is this? What Matt said? You swap it. What's a little bit more mathematical term? Reciprocal. Reciprocal. Took the reciprocal. Reciprocal is flipping that fraction. Okay. You take the reciprocal. Okay.
Reciprocal of the fraction, right?
Yes. And it's positive. You're right, and make it positive. Okay, because when you take the reciprocal of it, you change the sign of the exponent.
Basically take what you already have. So like it's the existing exponent. Taking away, if you're using a positive, or if you want to change it to positive, you take away the negative, and then the 1 will go on top.
Yeah.
And then if you're making it negative, or being positive,
You flip it, and
Yeah.
change the sign. Okay? Flip it, change the sign. That's exactly what ends up happening. Okay? Okay, so last little bit here. Right? Using positive exponents. We want our final answer only with positive exponents. So who can help me out with 12? Ethan. You might, okay. He's seeing it one way. That's cool. So Ethan is seeing it this. Uh-huh. Just 13 to the 7th. That's what he's seeing right now. Okay, and there are lots of different ways to get to our answer, and that's fine. Okay? I wasn't anticipating him seeing it that way. This is cool. Now, I've got some multiplication going on here. What's 1 times 13 to the 7th? 13 to the 7th. Oh, no cross multiplying. Cross multiplying goes on a diagonal. What's 13 to the 4th times 1? 13 to the 4th. So it would be 13 to the 3rd. Okay, that's how Ethan saw it, and that's mathematically correct. Who saw it a different way from the beginning? Lucas.
I saw like you add -4 and 7s.
Yeah. So, well, careful. Back up what you just said. We've got multiplication, we've got like bases, so this would equal 13 to the what? What's -4 plus 7? 3. Isn't that the same answer? Yeah. Two different ways to get to the same answer. Both mathematically correct, both acceptable. 13. X to the -7 divided by x to the 4th. Go with your basic instinct first. We've got division. When we divide, what do we do with exponents? Okay.
You subtract.
Okay. So what do I get?
So you would get -3. Or no, just 30.
Remember, when we divide, we subtract our exponents. So it's a -7 minus 4. So it's -7 minus 4. Right.
11. So x 1 over x to the 11.
Okay, so let's back that up. So x to the -11. Now, Bart gave the final answer with a positive exponent. So we took what we learned today and said, okay, this is 1 over x to the +11. That would be the final answer.
When you break that, this is from the -7 plus the -4 with that
Minus a +4? Yeah, we can do that. Okay, or, yeah.
You could 11 if you just subtract that.
We did subtract because if it is, so -7, we have to subtract that +4. Subtract a +4.
Oh, so you're actually
Weird. Because of integer rules, yes. But the exponent rule, make sure you are subtracting. Okay, this is subtracting, but to get to that answer, yes, because they're like signs we add. All right, 14. I'm going to write it differently. I'm going to write it as a fraction. And I'm going to put a 1 there. Oh, thank you. Thank you. Okay. So let's deal with the 9 divided by 3, the coefficients. What's 9 divided by 3? 3. Okay, we know that. We've got like bases m's. When we divide and we have like bases, what do we do with the exponents? Subtract. So what's my first exponent? 1. And what's my second exponent? So I've got to subtract. 1 minus a -2. So what is 1 minus a minus 2? Okay, good with that? All right, let's rewrite this one. As a fraction. Do I have like bases? Yes. So I know my base is x. Now I'm dividing. So what do I do with exponents? Subtract them. So I have a negative 7 minus a minus 4. What's negative 7 minus a minus 4? Ethan. Negative 3. But my directions say I want all the answers with positive exponents. How can I rewrite that? Bing. 1 over x to the third. Awesome. Yep. All right, next one. How about this one? What's my base?
-6.
What's my base?
Parentheses.
Parentheses negative 6. So I know that. Dividing. What do I do with exponents?
Subtract.
Subtract. What is 3 minus 4? Negative 1. I got to write it with positive exponent. Okay,
So can't you just put it over 1?
tell me what to write.
So you would do 1, then
Over.
over parentheses, -6, parentheses 1.
Perfect. Yep, positive 1.
You make-
Yep. Do what?
you guys put the one-
No, that's understood. You don't have to.
Okay.
Okay. All right. Last one, right? 17. Numerator. Numerator. Ethan. Yes. 7 to the negative 2. Denominator. Tony. I think I'm okay. Denominator. Tony. Jacob.
5, -3.
5 to the negative 3. But I've got to write positive exponents. Now I got a negative in the top and a negative in the bottom, and I need positive exponents. Garrett, tell me what to write.
So 5 is positive third over 7.
Perfect. Flipped them, right? When you flip it, you change the sign of the exponent. When you flip it, you change the sign of the exponent.